everybody. Konnichiwa. And I'll begin by asking, so was the earthquake scary? If so, raise your hands. I was scared. I was very scared. And I was with the students in Funabashi that time. And one more question, how about the radiation? Was it more scary? Or did you have no information at all? So, if it was more scary, okay, yeah, quite not many people. So that means there was lack of information about radiation. That's not a good thing, but that's a start. And I'll talk today about 3 R's. R's. The first R is Randeep. The second R is rice. The third R is radiation. And there may be a fourth R, the rat. Okay? So, it's been a long journey from India. So I was at the Delhi University studying plants, plant biology, botany. And plants just fascinated me. It was they're beautiful and they smell nice and I like to eat them. So it's nice. And plants led me to a master's degree in agriculture that was concerning plant pathology, disease at Plant University. It's just below the Himalayas. It's a very nice place. Very rural area, very nice place. And from Pandagar, I came for my Ph.D. to Ibaraki University, School of Agriculture. So plants to agriculture. And in between, sometimes if you stay too long in Tsukuba, people want you out of Tsukuba. So many people told me, just Randeep, leave. So I left for Tokyo, the T. So it was the School of Medicine, Showa University. Because I started work also on mental stress, neuroscience, anti-aging medicine, and DOHAD project, Developmental Origins of Health and Disease. So it was a nice break. 1 year at Showa University Medical School. Broadened my horizons. Excellent. And then, once you're out, people want you back. So, Tsukuba University, University of Tsukuba to be exact. And we have a graduate general education program in the university. So I was asked, can you come and advise, just guide or just deal with the international aspects in English in the program? It was after 311. So I said, perfect, why not? My first job. Yes, I'm ready. So I came to the university. And even though I was teaching graduate general education, managing the program, talking with students, ranking with students, I continued my work on rice, the second R. So rice is really very beautiful. So if you have passed through the rice fields, I do every day. Iitate, I live in Iitate, so I've come to the university via rice fields. Very beautiful, very, very beautiful. And they're very green. For me, it's green gold. The fragrance, just the leaves moving through the wind. They're very, very beautiful, fascinating. And of course, it's golden rice. It's gold for the human population. And if you look at the rice farmer in Japan, he or she, for the rice farmers here, it's life in general. It's a job, but it's also a passion. It's culture, it's society. It's everything for them. And they are well paid. It's a wonderful job. But if you look at the rice farmer in India, these are not rice farmers. These are daily wage earners. They come from faraway villages and cultivate rice for the landowners. Landowner is enjoying drinking his afternoon, usually his cup of tea or drinking whiskey at night. But these poor farmers, they come, for them it's life and death. That is all they have, rice. So rice is fascinating. So how about radiation? It's a hot topic. Last 2 years we have been talking, hearing, listening, debating about radiation. So how many of you know that the solar power we generate these days is also moved by ultraviolet irradiation? Does anybody know? UV irradiation is a part. Thank you. So the next generation solar panels generate solar power via UV radiation also. This is on my house because I'm not anti-nuclear. Or why? Because I have been enjoying the fruits of radiation generated energy. I have everything. There's 100% electricity, I can work, research, enjoy. I can't say I'm anti-nuclear now. I have to give up something, I have to sacrifice. Yeah. So I have been, so this is my contribution for a start to radiation. So at least try to support. Next. So this is what we love to hate, radiation. The nuclear radiation, radiation from nuclear fallout. And maybe, I'm not sure how many of you have seen radiation. Has somebody seen radiation? Maybe not. Okay. Good. So, sorry. So when we grow, so this experiment is just, this image actually is just to show you what radiation looks like. You can visualize it, you can see it. So I grew rice seedlings in soil from Chernobyl. It was more than 10 years back. And rice plants, seedlings, take up the radiation. It has cesium, it has other compounds. And we can see that it's glowing using an X-ray film or an imaging plate. It's glowing. The control radiation, we put a determined dose of cesium-137. Of course, it shows some. So that means the soil actually is more radioactive, which is a fact. And it has more components than we know of. The controlled soil has nothing. So we can see radiation. And we can also hear radiation. So in the news, you might have heard this song. We don't like this sound. We really hate it. It's really very terrible. So this is a radiation dose meter, which I used in Fukushima. It was in Shirakawa. So Shirakawa is a town next to Koriyama. But luckily the radiation cloud didn't reach up to Shirakawa. But still, we can have a dose of 0.2. So 0.2 microsievert per hour is the dose which we can find in Tsukuba also. Many places it's 0.3. But nobody knows what the dose was post or pre-Fukushima. Nobody knows. There's no data. So at least our job is to have information, knowledge available on the web so that you know what is there. And in a few minutes, a few seconds, it will go up to 2, 3, 4 microsieverts. That's 100 times, to be exact, 70 to 100 times the background. 0.05 is the background. So 0.2 is now considered maybe normal because we have it almost everywhere in Japan. And it just goes up to 2, 3, 4, 5. At 100 times, we can't stay there. Thank you. Yeah, so it's increasing and I hate the sound. I hate it. Okay, let's move to the. Thank you. Okay, so I told you I've been working since almost 10 years on radiation, and we first started with, on the left screen, the soil from Chernobyl. It is just 5 times the background. 5 times. It's not 100 times. But still, when I did a very simple experiment on using normal soil or soil with contamination or radionuclides, we could see subtle difference in the color of rice leaf segments. And of course, the molecular molecular components, biochemical properties changed. So that was the first experiment which showed that very low level, ultra low level of radiation can have biological effects. That's very important. High dose of radiation will kill you, will kill plants. That's nothing new. It's okay. We know that. And in this radiation journey, one of my closest friends is Dr. Shinzo Kimura. So he brought the samples. He said, "Are you interested to study stress, radiation?" I said, "Fine, let's go." So this was the first experiment. On the right, then we started working on radiation independently. Saturday, Sunday, it's like part-time research. It's actually part-time research. And I used facilities around Japan where I could get hold of the radiation, be it cobalt-60, be it carbon-ion beams. And one thing which we saw, that radiation suppresses the growth and development of plants. That was another research, result. And that we repeated for last 8-9 years. And has anybody heard of Abenomics? So, in biological science, we have omics. It's a term which we use. So Abe-san has taken that word from us, so we can sue him, okay? But omics is the study of the whole cell, organism, system, totality, in total. So what we did, so technology, that's a key word in TED, technology. So the left-hand side shows each spot, colored spot, which has been generated by firing a laser, shows the gene expression change. How your gene is being changed under a particular stress. So that we employed to study effect of radiation on rice. It's very beautiful. The effects are not beautiful, but the image is beautiful. And on the right hand side is the protein. So I think you all know about protein. So we can visualize individual protein spots, individual protein, a single protein encoded by a gene, and see whether it has changed by radiation. So we used technology, specifically omics technology, to identify the changes caused by radiation in rice. So that was the background. And then suddenly, out of the blue, Fukushima Daiichi. So maybe you have seen that image of the clouds and people panicked. I was here in Tsukuba. Luckily for me, I had information. My friends are radiation specialists. So they were in Fukushima after that day. So I had information, so I didn't go anywhere. I tried to tell whoever I knew, hey, stay here till I'm here. If I run away, let's go. I'm not going to leave my neighbors and run away now. Because I have information, so I could say that. So information is key. Luckily for me, but unfortunately for the public, the information on radiation was lacking. And then started the journey to Iitate or Iitate village. And you can see this green dot asterisk there. So this is the Iitate village, and this is the place where we did our experiments. You can see from FNPP how the radiation cloud fallout is deposited, and it's a highly contaminated area. And this is Soma, which is least contaminated. So these two are our experimental areas. And this image behind me, the entrance to Iitate stuck in my mind. I stopped and took the photograph the first time I went here. And this image is in every presentation, I think. But it tells me that beyond this point is desolation, deprivation, human tragedy. That's the fact. So that's the D maybe in the TED. It's not designed, but the image is designed. And when we went to Iitate, so we had to do an experiment as a researcher. So we had to plan the experiment because it's not a normal experimental setup. It's an abnormal situation. We can do experiment in the lab. I did 10 years, but this is not normal. I need permission. I need to see what are the radiation levels in the car in which I'm going. Will rice be affected by that? So we did that. We went repeatedly to Iitate and met with various people. So he is a friend of my student. He's now in Tokyo University. He's basically from Kyoto University, Research Reactor Institute. And he came and helped us download these drums. So actually these drums are the shielding boxes for rice, because we wanted to control the level of radiation into rice by using a sheet. We can't use lead. It's thousands of kilograms. Luckily, a company gave this to us free, and they had a new material based on some plastic and carbonate. It's a secret, so I'm not sure what material it is, but it can shield the rice from radiation. So we can control the dose. We want to have 5 times the background, 50 times the background, 100 times the background. So that was our experiment. And if you go to Iitate, you will see decontamination, or josen. Thousands of bags, black bags, from just one field, this size, maybe a little bigger than this. So you can just imagine where to keep all this decontaminated. So it's not possible, that's a problem. That's why this image is there. And this is now my friend, Negro-san. He's a rice farmer in Iitate. He's staying next to us where we work in Iitate farm. And his rice fields, he has been waiting for 2 years, now 3 years, to plant rice. He said, I'll grow rice. That's the last thing I do, I'll grow rice. And he's still. So this year, last month, he has planted koshikari and hitomebori. So we will start our next experiment with his help. But he said, I'll do it. And I will not wait for the government to decontaminate my soil. He will do it. So we need, as researchers, I need to help him see what are the effects. That's my job. And put that information to the public. So what radiation does, it stresses rice. It's a stress, very simply. But a stress which we usually cannot see, which we usually cannot hear. So that's the problem. But it's a stress, very simply. And I'm not sure you have seen these images or read. Somebody of you who is a student or a researcher might have seen some of the results which have been published. As I said, rice, this is radiated for just 13 minutes with carbon ion beams. And you can see the growth has completely stopped. And this experiment was done with gamma radiation using cobalt-60 as a source. Highly irradiated, 270, it's a high dose. It's not a low dose, high dose of radiation. Medium dose and control. So rice, after the irradiation, were transplanted back into the soil and they died. Even the low dose died. So radiation, of course, is harmful. And what we found at Iitate, which was the most critical, is that rice leaves, the young seedlings, so this has nothing to do with young children or old adults or mature adults. This is young rice seedlings that are experimental. They start to die from the tip. And this I have observed for last 10 years. This is one of the days. They start from the tip. I don't know the reason. I haven't got to that point. So this was 100 times the background radiation. And to work with society, or work with specifically Iitate, the villagers, some of whom are still there, very few of them. So we have a society for radioactive, so that we can communicate, talk. We go there, we have meetings, seminars in Fukushima, in Iitate, in the farm. So the villagers come and talk. Researchers come, present. So if we go there, we don't just sit in Tokyo and talk. We go there, physically talk. And try to understand what they want and how we can present our data. So this is what is our contribution towards rice. And finally, last 2 years, Fukushima is in general being forgotten. That's a fact. It's they and us. Fukushima, the people in Fukushima have a different set of rules. That they can stay in Fukushima or contaminated areas for within 1 millisievert, that's very high dose. But people in Tokyo or outside Fukushima, the level is 0.1 or 0.2. That's a big bias. You can't, there are thousands of people there, children living next to Iitate. So how can we just forget them and not do anything and just talk and talk and talk? So I don't want, especially the younger generation, to forget. I went there again last month. So what hits me is always the signboard, Iitate village. And I took my son. Up till that point, of course he's not allowed inside. I know it's dangerous, but up till that point it's around 0.6 microsievert. So I took him, so that he at least remembers, knows what I'm doing and what Fukushima is, what Fukushima now means to the Japanese people, to the world. Thank you.